Hello and welcome to this week's edition of Google Cloud Talks by DevRel. It's Thursday, July 9th, and Google Cloud Talks by DevRel is this ongoing series of presentations by Google developer advocates to address topics that are most important to you, the developer community. Today's session focuses on how you can optimize your app development with Google Cloud. You can always find out more info about our upcoming sessions, and you can register at events.withgoogle.com/google-cloud-talks. I'll paste the link into the live chat, which reminds me, there's a live chat. So feel free to chat with the presenters there, drop your questions in, and we'll also have a slides Q&A system where you can upvote questions and kind of ask questions more straightforwardly there. So yeah, and if there are other topics you'd like to see in the future, please feel free to share them with us through the Q&A or in the live chat. Today, we've got two great presenters, Don McCasland and James Ward. They'll be talking about speeding up your Android builds using the cloud, as well as building Kotlin on the server, as well as Android. So kind of giving you the full stack Kotlin experience, I guess. So let's bring them on so they can say hi. Here they are. Don is a developer platform engineer focused on CI/CD systems with over 20 years of experience in DevOps and release engineering. And James is a software developer with over 2 decades of professional programming and is now a self-proclaimed typed, pure, functional programming zealot. But he often compromises on these ideals just to get stuff done. He's a huge open source proponent and hopes to never get burned by lock-in again. So with that, how are you guys doing today? It's great to have you on.
Oh, it's a good day. Yeah.
Beautiful here in Colorado, and yeah, good to be here and get to talk about Kotlin.
Nice. So you're in Boulder, James, or Boulder-ish, up in the mountains.
Up in the mountains, the little ski town called Crested
nice.
Butte.
So are you at altitude then? I guess.
Yeah, we're at
9,000
feet,
I didn't.
So if I start getting short of breath,
wow. So this is really Kotlin in the cloud.
We're up there.
That's
right. Yeah. I'm in the cloud. I live in the cloud.
So that we can attribute your amazing fitness to being a mile and a half, almost 2 miles above sea level.
Trying to survive all the time. Yep.
Excellent. Yeah. So for folks who are joining us on the live stream, feel free to let us know what you've been up to and where you're joining us from around the world. I know we have people watching typically from, not just various countries, but multiple countries, all sorts of time zones, all sorts of continents. Yes.
Yeah. Have you ever had anybody from Antarctica?
That would be pretty cool.
That would be awesome. I hope somebody's on from Antarctica. I went ahead and chatted in so that we see the chat a little bit, presenting from Oakland. So
nice. Yeah, we have Brijesh saying hello from India. So, and Chile, Felipe, a different Felipe from the Felipe we know at work, but another Felipe from Chile.
That's awesome.
All right, so I guess with that, first up, Don's going to be talking about, that's right. Felipe says not Hoffa. He knows the alternative Felipe options there. So that's pretty funny. Awesome. So Don, you want to get set up? We'll talk a little bit about what we'll be talking about. Talk about what we'll be talking about.
Yeah, sure thing. Let me present my window, and I'm going to be looking up at my big monitor here, so that's what it'll look like. You'll see the underside. Let's see. So what I'm talking about today is how to speed up your Android builds using Cloud Build. So the deal with Cloud Build is it's most commonly looked at as a cloud native build tool. It is usually best in a setting where you're building an application that is going to be deployed on GCP or AWS, deployed in the cloud, or if you're having to do Google Cloud orchestration, Cloud Build is commonly used for that. But there are some other use cases that may be a little more unusual. People have used it to do all kinds of things. And one of my colleagues reached out to me when we were planning for Cloud Next. He said, hey, I know people are using it to build Android. Have you done that? And I said, no, I have not. He said, will you give it a try? I said, absolutely. I would actually love to use Cloud Build for this. In my past, I've always had to maintain a rack of servers in the closet for apps builds. A lot of that has to do with when you're building cross-platform apps, iOS apps along with Android apps. But the truth is, managing a set of servers in the closet is really painful. And especially if you have a small closet. Like you're constrained by everything from, power, network, cooling, and space. And in the Bay Area and Silicon Valley, all of those things come at a premium. So managing app builds in the cloud is a really good thing, but I hadn't done it. So today we're going to take you through some of the things I learned as I did it. So here's how it started. First thing I did was I looked at the supported builder images provided by Cloud Build. If you do the Google, you'll find this list. And then if you look at the complete list, it's going to take you to GitHub. And this is the list of officially supported builders. And there isn't really an Android one in here. There's Bazel and curl and Docker and .NET and gcloud. There's Java C. That's a good start. There's Gradle. Both of those are good start for building Android builds. If you Google around for Android and Cloud Build, you'll actually see a few examples that build an image based on Java C. Cool. Well, so I actually followed that example for a little bit, played with it. I wasn't getting quite what I wanted. And then I probably should have very quickly looked over at the Cloud Builders community builders. So the community builders are not officially supported by Google, but there's a fairly active developer community around these. And right there is the Android builder. So this is where I ended up. So if you look at the Android builder in GitHub, there's a great detailed README that tells you how to get started, and it's fairly simple. So the cool thing about this builder, about this container image, is it's got a number of customizations, including the ability to add a build number. You can build the builder at different versions of the Android SDK. And why would you want to do that? Well, one of the problems of managing app builds is managing the development environments. I can't tell you how difficult it was to have a closet of build machines that needed different development environments for different stages of the development. Like if somebody wanted to move to a new version of Xcode, we either had to use some machines on one version of the Xcode or other machines. And then we ended up managing it with VMs. So we had VMs for that. But loading VMs onto a machine is a massive hit to how long it takes to build. So with containers, you can actually pre-build and deploy your Android SDK at whatever version you want. So by default, this will build to Android SDK version 28. But as you'll see in a minute, we needed something different. So let's take a break and talk about the app that we're building. We picked one. The app that we're building is the Google I/O Scheduler app. This is a real app. If you take a look at it, this is what we give to our conference goers, anybody who's going to Google I/O, to help them figure out which meetings and presentations they're going to see. So this is a full-featured app that includes a backend gives you information about the venue. It's all of this. And it's written entirely in Kotlin and the Gradle build system. So our plan was to make this app work in Cloud Build and make it build faster than you would cleanly on other systems. All right, that's our challenge. So to do that, I found out somewhere down in here, you will see that it needs Android SDK Studio, SDK version 29. So here's what we do. So the first step in using Cloud Build with builders that aren't supported by Google is to build the custom builders and deploy them. All right, so let's say we have a
Here's an answer from Google.
Oops. So let's say we have our Google project. So the first thing you do, you create a Google Cloud project. You enable the Cloud Build API. That's easy. You enable the container registry API. And then let's activate Cloud Shell. And let's pop it out into a new window. So at this point, this project, let's make sure that we're using the right project. Set project. Grab it from here. All right, and let's close this over here. Go back to Cloud Shell. So I have already cloned the Cloud Builders community repo in my Cloud Shell. That's already done. You can see it here. We pop down into Android. You can see the Cloud Build YAML. So to build and deploy a custom builder for Cloud Build, we're going to use Cloud Build. This is pretty straightforward. So all I have to do is copy and paste this line here, and let's substitute with version 29. Now, this actually takes a few minutes to build, so we're going to skip ahead. It's just like a cooking show. I've already done this part of the process. I'm going to show you in container registry here in my project that I have Android builder tagged :29. So the way that you would manage this if you had multiple versions is you would say, build this multiple times with 28, 27, whatever it is that you require. And it will build, push, and tag for you out of this Cloud Build YAML. Now, the other part of this, if we go down the README, is that we need a set of buckets. So these buckets are used to store build artifacts. So if you want the APKs and the other debug elements, everything that your build delivers, you want a bucket to store them in. It also allows you to, the build config allows you to do build numbering, and the build cache allows you to speed up the build by delivering cached results and then unpacking them at the beginning of the build. We're going to show you that later. Another thing that is not spelled out here. So there are two gotchas. First of all, here's a gotcha. So if you're following along at home and doing this, do not actually do gsutil make bucket my build artifacts. And the reason is because storage buckets have a global namespace. So every storage bucket in all of its existence has to have a unique name. So my build artifacts, if you try to create this, it already exists. So you won't be able to create it. I named my buckets with the project ID numbering dash build artifacts. So 282019 build artifacts, 282019 build cache, 282019 build config. So those are my 3 buckets that have build artifacts, cache, and config in them. There's another gotcha that's not mentioned here. So to understand that, we're going to look at the cloud build YAML that is an example. Here in the Android community builder, there are a set of examples. So let's actually pick one. Let's just look at the simple cloud build.yaml. That's mostly what we're going to follow here. So in a cloud build YAML, you have a set of steps. Each step has a name. That name indicates what what container is used to build that step. So here, this step is using gcr.o cloud builders gsutil. That is one of the cloud builders that are that's one of the cloud builders that are supported by default and available by default. Here, in this step, we have a gcr.o project ID /tar. So whenever you see something like this in your cloud build YAML, you know that this is a custom builder. This builder has to be built and deployed into your project. So we've already built the Android builder, but we haven't built the tar builder. All right, well, all right. So this is a gotcha. We will go back and build the tar builder. Let's find the community tar builder, or let's find a tar builder. Let's see, down here, there's a tar builder. Excellent. All right, this is good. So all it needs to do is basic cloud build submit, and then we're off to the races. So I have this here. I'm in the Android. I'm gonna back up. I'm gonna do a gcloud build submit --config. Actually, I think I can just use the default, and we can build the tar builder. This will take just a moment, but then we'll have the other piece of the puzzle that we need. And I can show you, while this is building, I can show you that we're building. We'll pop over to cloud build. Using cloud build to build the pieces of our puzzle that we need to build. And Mr. Dr. M, what is your advice on the Flutter optimizing app development with GCP? I actually don't have an answer to that right now. I don't know what Flutter optimizing is, and I'd be willing to talk to you about it more. So let's go. So this is done. This is ready to go. So now we have the tar builder. Let me show you that in container registry. We'll go to tar. We've got it. So now we have an Android builder and a tar builder. And if we look at Android cloud build example, so our task is to modify this to do what we need with IO schedule. So that's what I've done. I'm going to open the editor here. I have cloned IO schedule into my Cloud Shell already. And what I did was I took a look at the build Android release script, which tells me, all right, it does a clean assemble, and then it grabs some APKs out of this directory. So what I did is I wrote a cloud build YAML. Let me make that a little bit bigger for you. And you can see, actually, let's pop down here. I do a Gradle W, Gradle wrapper, clean and assemble, using a cache. and then I grab everything out of mobile build outputs. So that's it. That's really the meat of the matter. It took me a little bit to get to this. We'll talk about that in a minute. So let's talk about the cache steps. The first step in this is to try to copy from the cache bucket. If nothing is there, this won't fail. It's okay. And then we untar it. It says this might fail the first time, but that's okay. We actually continue on if it's the case. We say echo no cache found, no big deal. And then here's the key point. We set an environment variable called Gradle user home to where we unpacked the cache. And we'll show that in just a minute. So this is really all we had to do. I did write a little helper script because we do some substitutions in this cloud build. You wouldn't have to. You could hard code your buckets, but we put the branch name in so we can allow building from multiple branches. And we specify the buckets for artifacts and caching. So let's run this thing. Let's pop over to IOSCED and let's start a cloud build. I'm going to check all my chats. All right, this is good. This is good. All right. So now that this is starting, let's go back over to cloud build and look at what we're seeing. So we got 6 steps. Here shortly, the logs will start filing in. And this shouldn't really take too long to run. When I timed this on my MacBook Pro, a clean build with no cache took 13 minutes. And with a cache, it took about 7 minutes. And this is just on my MacBook with probably a lot of other processes running. So on a containerized build, we're going to take a little bit of performance hit, but not very much of one. We're going to start it up with a larger machine. So that actually takes care of the VM overhead. And we went ahead and gave it a fair bit of memory. For the Java heap. And I'll tell you about my process of discovering what I needed for memory in just a minute. All right, we're 51 seconds in. Let's see here. We've already got logs running to our console in Cloud Shell. We're already at step 2, so that's good. I'll go ahead and take you around this. So if you look at the build summary, you can start looking at the execution details. So this is stripped from the cloud build YAML and the running build. You can see here the Google storage bucket that contains the source that we're building, because it's always we always build from a tarball of the source from where the build was started. So it gets tarred up, put in a storage bucket, and then you could actually download this source directly and manipulate it on your local development environment if you needed to reproduce a build problem. You can see the substitutions that we put in: branch name main, cache bucket, artifact bucket. What else? Here are the current build artifacts. Oh, no artifacts to display. And then back to the build log. Ah, good. So we're starting into the Gradle build. You can tell because it's saying task this, task that, so forth and so on. Starting to get its work done. So tell you what, while this is building, we're gonna talk ahead a little bit. I'm gonna show you the history of builds and show you that it wasn't always so easy. If you look down here at the beginning, one of the things that I struggled with in setting up a Gradle build was I'd build a symbol. I'm just gonna pick one here. All right, so invalid heap size. So I was really trying to give the heap size on the command line, and that failed a bunch of times. I manipulated that in different ways. And then, okay, that one, not a good example. Let's find a build breakage that shows you what I want. Yeah, here we go. GC overhead limit exceeded. So one of the things I kept running into was how to optimize this build for the Java heap space. And one of the first things I did was make the Java heap space really, really big, like 12 gig. Finally got it running. But as I looked around and looked at Gradle, I started finding out that there are ways to optimize Gradle for performance. There are a number of options that you can specify in your Gradle properties or your command line. I find that Gradle properties is a really good space for it. Caching, we definitely get an advance from caching. Configure on demand for Kotlin projects doesn't actually do a whole lot. The daemon. So a daemon is really useful in your local development environment, but you take a penalty for starting the daemon in a containerized build environment. So unless you've got a always hot VM that you're building on, we should set daemon to false. Parallelization turns out to be a great advance. One of the things that I learned was how to use Gradle Scan. So if you want to understand your Gradle performance, you can add this command line option to your Gradle build. So I did this in my local development environment. I said --scan, and at the end of it, it gave me a URL that it was automatically generated. Once you get that URL and go to it, you can start to understand your build in depth. So it can tell you how many tasks you had, how it was divided into projects, the total build time. So 8 minutes, that's from a cached build. And then you can actually start looking at the performance, which is really interesting. And you can actually find out what your peak heap usage was. Your cache hits. So in this case, we got 129 cache hits and 234 cache misses. If you're trying to optimize your build, you can actually start working on the dependencies. You can start looking at what had to build in what order to make your build faster. All right, we got a build done. This is good. Let's go back to it. So in our world in Google Cloud, with all the optimizations, we're able to get the build in 5 minutes. 6 minutes after you unpack and repack a cache. So this is actually a pretty good optimization. And I found it a really great exploration of how to get this done. So a 5-minute continuous integration build with unit tests would be acceptable in my world. So that's my presentation. If anybody has extra questions about this, feel free to put them on the chat. I'm going to hang out while James does his presentation and chat with folks.
Great. Thanks so much, Don. Yeah, for folks who have questions, we have the Q&A, so I'll pull that up here for us. Let's get the Q&A window.
So I see one from
Yeah.
Rajesh. There's not a quick lab exercise. However, I will share my GitHub URL that has this already built into it. So you could look at what I've done and take it apart and do it yourself.
And what is, just because I think you might not be able to paste it in. So it's Don McCasland.
I'm going to paste it into the lab.
I don't know that you'll be able to, is the reason I say that. Don.
Did that come up?
So by default, it blocks unless we add you as a moderator. So I'll be able to post this in for you, though. There you are.
Okay, great, thank you.
All right, so that's the GitHub link for folks. And let's see. Yeah, and so other questions, feel free to throw them on the Q&A for the slides or drop them into the chat. And I see James has joined us. Let me switch us out to this view. Sorry. There we are. And yeah, welcome back, James. Good to have you.
Hey.
So if we don't have any further questions, let's switch out the presentations. And you know, Don, I thought it was really interesting that bit where you showed that there were these community builders, right? And they were in the official repo. So folks can submit their own builders and we'll include them. That's great.
Yeah.
So yeah, if you're looking to, you know, get some code into the official Google Cloud Platform repository, you know, that's a nice little feather in the cap to some extent.
Sure thing. Yeah, we are accepting and moderating pull requests.
That's right. So make your pull requests, get your work out into the world.
All right. Well, thanks, team. Take it away, James.
Thanks, Don. All right. So we're going to move on from that to talking about using Kotlin on the server and in your Android apps. And you can find me on Twitter _JamesWard. So just a couple slides, and then we're going to do a bunch of code. So Kotlin's been around since 2016 from its 1.0, and it has received a lot of adoption on the Android side of things, which is awesome. Really creates the foundation for a great programming model for Android apps. But lately, it's also been getting a lot of adoption on the server side. And so that's what we're going to be talking about mostly today is Kotlin on the server side, but then how to combine that with Kotlin on the Android side as well. Kotlin now is the #2 language on the JVM, which is pretty exciting. Kotlin's got a huge community of adoption, mostly on the Android side today, but significantly increasing on the server side as well. The Google Home app, they rebuilt it in Kotlin and immediately saw some huge benefits in how quickly they could move, reduction of null pointer exceptions, and less code and all that kind of good stuff. So we're using Kotlin at Google to build stuff, and we're also a core contributor to Kotlin. So when you want to do Kotlin on the server, there's actually a bunch of options that you can go with. There's a framework which you're going to be using today called Ktor, which is sponsored by JetBrains, an open source framework. There's also Spring Boot has great Kotlin support. And there's another newer framework called Micronaut, which as well has great Kotlin support and for server-side development. And then another option recently is Grpc, which we'll be talking about in a little bit. So I'm going to start with a code sample that that I built for this presentation, and it's just a really simple code sample. You can find it up on my GitHub, and that's James Ward on GitHub, and then Kotlin Cloud Android. And so this is the source code. I've got it open locally in IntelliJ. And so what this application is going to do, what we're aiming for, is when I use Kotlin, I always have a hard time figuring out what the latest version is. And you can use the GitHub API to go get all the tags in the Kotlin repo and see what all the versions are. But these include like milestone releases. Here's the most recent official full release. And so that's 1372. And so I was thinking, hey, why don't we build a little application that will, on the back end, go hit this REST API, figure out what the latest version is, and then we'll render that into an Android application. So that's what we're aiming for. So let's walk through some of the code for this project. In this project, I have the Android UI. I've got common code that's shared between Android and the server, and then the server code. Let's start with the server and go check that out. So you can get an idea for the Kotlin pieces. So first, we need to have a way to start the server. So this just uses a main method on a class server. And we need to figure out what port to start on. When we're running in the cloud, that port may change. And so we use an environment variable to read that port. But if it's not set, then we just default to 8080. For local development, I want to be able to watch my classes to see when they change, and then Ktor will automatically reload the server whenever it's recompiled classes. So that's nice for local development, but I want to turn that off when I'm in prod mode. So that's a little bit of setup for that. But then I start create an embedded server. I'm using CIO. You could also use Netty. I think there's other backend HTTP backends that you can use as well. CIO is a Kotlin Ktor-based NIO HTTP server. Give it the port, give it the watch paths, and then give it my application module, and then I tell it to start it. So that's how we start up the Ktor server. And now let's go look at that application module so you can see what's in here. So in my application module, I'm going to be making a HTTP call out to the GitHub API. So I need an HTTP client inside of my HTTP server. And so I'm going to create a HTTP client. I'm going to turn on the JSON feature, and then I'm going to use Kotlin X serialization for my JSON serialization. I'm going to install a few other middleware pieces into my server, the default headers, call logging, content negotiation so that I can produce JSON in a response. And then I'm going to set up routing. So when I set up routing, I can set up the get handlers, the post handlers, all that kind of stuff. So I'm going to handle a get request to slash. So whenever there's an HTTP get request to slash to my server, what I'm going to do is I'm going to use my HTTP client. I'm going to do an HTTP get out of here to that URL that has the list of tags. I'm going to tell it to deserialize that JSON into a list of release, so then I get my releases back. But what I want to do is I want to get the latest release. So I'm going to filter out all the ones that contain a dash. That's just my hacky way to filter out any milestone or other releases. Then I'm going to get the first one. They're ordered, so the first one should be the latest. And then I am doing this or null, because this allows us to, let's say that we don't get any releases, then we want to be able to know that and handle it differently. And then we're using the question mark syntax, which is the Elvis operator, null safety operator in Kotlin. So then it allows us to have logic for when we have one of these, and then we can respond in a certain way. And sorry, my printer decided to just start printing something. Awesome. So it's nice and loud in the background here. Let's turn that off. Sorry. Okay, so then what we're going to do is the question mark colon and give it the when it was null, and we're going to just return not found. Okay, so that's our whole server there. And so now let's go and actually run this thing locally. So I'm going to have one window where I run Gradle and then server classes, and I'm doing this -t, which means do this continuously. Run this thing continuously. And so it's just going to continuously recompile those classes in the background. And then let's have another window where we do our server run, and that's going to run our server main class here and start up the server. Okay, so our server is now going to be up and running. We'll be able to test this thing out and make sure that it all works locally. So there we go, up and running. Let's go to localhost 8080. That's going to go make that request to the GitHub API, get those tags, do the filtering, get the first one. And there we go. We see the JSON response that the latest Kotlin version 1.372. Great. So our backend server is working normally. One of the cool things that's happening here, kind of hidden underneath the covers, is this is using Kotlin coroutines. So when I do a GET request to that, it's actually going to be a non-blocking NIO-based request, and you'll see that this returns this is a suspend fund. So this is a coroutine, and so because I'm in the coroutine, it's going to be non-blocking on the HTTP request, and so that's great. But what happens if I try to make a request to a repo that doesn't have any tags? Let's do my James Ward Kotlin-samples, which I know doesn't have any tags. And now when I save this thing, then go back to here, you'll see that it's going to recompile that class, and then the server is should automatically restart. Let's go back to the right window here, restart. And now if I go reload this, then it's giving me a 404 not found response from that request. So that was nice, combining coroutines, null safety, some great features there with Kotlin. Okay, so we've got our basic application that's able to handle this REST request to the GitHub API, producing a JSON response. Cool. One thing to go look at real quick is I'm deserializing this into a list of release. But what is a release? That's something that we're going to share between the server and the client. So one sec, while I unplug my printer. Okay, the joys of presenting from home. Okay, so let's go look at our common library here. And in our Kotlin, here's our data.kt, and we have a data class that is release, and then we mark it as @serializable, so the Kotlin X serialization library can serialize and deserialize this thing. So that's our shared data between our client and server. Not very complicated, but a simple example there. Okay, so we've got our common, we've got our server. Now let's go look at our Android application. And for our Android application, also built in Kotlin, this is going to, first, we need an HTTP client. So within our Android application, we're also going to use Ktor's HTTP client. So you've seen the code for that before. And then when we create our UI, we're going to go get the URL, which we'll talk about in a little bit, for how to talk, where to talk to the service. Then we're going to go make an HTTP request to that URL to get the latest Kotlin release. And if that fails, then we have a fallback there. So our very basic UI here is just a linear layout with a text view that we're going to render that into. Okay, so let's go run this in our local Android emulator and make sure that this thing is actually going to work. And while that's getting up and running, I should probably go switch back my code to talk to the Kotlin repo instead of mine that doesn't work. So that was JetBrains and then Kotlin. Okay, so I'll save that. That should reload, and we can go verify once that's all reloaded in a second that we get the latest release there. But while that's loading, yep, you'll see it tried to load and couldn't because when it called it, it didn't have it. So let's go try this, try to go run this thing again once we know our server is up and running and getting the latest release, which should be happening in just a second. So it's going to make that request to the non-blocking request to the GitHub API and then get the latest release and then should render that there. So let's see. It noticed that our application had changed and reloaded it. And sometimes the GitHub API takes a little while. So that's probably what we're waiting for here. Yeah, so the GitHub API is taking a minute to respond. Let's try again. Come on, server. And when all else fails, oh, there it goes, finally came through. Okay, so there we go, we get the latest release. Okay, now let's go back into the emulator and let's go launch our application again, which is this one, I think. Okay, there we go. Great, so now our Android application, sure enough, is making a call to my local server, which is making a call to the GitHub API to get the latest Kotlin release, and then rendering that there in my Android application. Okay, so now we have end-to-end Kotlin. That's great. But what if we want to take this application and get it up and running on the cloud? Well, we can do that very easily, because in this repo we have this button which is Run on Google Cloud. And so what we're going to do is we're going to click that button, and it's going to say, "Are you sure you want to open that repo and run it and build it and deploy it?" And I'm going to say, "Yep, I trust it, so I'm sure." So what this is now doing is it's in Cloud Shell, which you saw in the previous session, which is just a compute instance just for you in the cloud, and this will automate the steps needed to deploy this application. So I have to tell it which GCP project I want to use. JW demo, yes. And now it's going to walk through a few steps. I need to tell it where do I want to deploy it. I'm going to say US Central 1. And now it's going to take the source code and just the server in this case and build it. And so the way that it's building it is using something called build packs, which are a CNCF, I think, incubating standard, which takes source code and turns it into something that can run. And so it's saying pack build, it's giving it the coordinates for where to store the output of this build, which is on the Google Container Registry, my JW demo project, and then a name of a container. And then the path to build, which is just the path to my source code. And then the builder that we want to use, which is you can specify different builders and with CNCF build packs. So I'm using the Google Cloud build packs here. You could also use Heroku build packs or Paketo build packs. There's different build packs, but ultimately what's going to happen is it's going to look at this application, the source code, and say, "Oh, I know how to build that. It's a Gradle build." And so then it will take the Gradle build, run the Gradle build, which will download Gradle, download all the dependencies, and then produce the actual application that can run just using the Gradle assemble task, and then package that all up. So what it gets packaged into is kind of like a big zip file that has everything that's needed to run this application. This is based on Docker containers, and so we could, once this is finished, run this Docker container anywhere. And Docker containers are the way that that Cloud Run, which is what we're going to be using to deploy this thing on the cloud, how the deployment unit that it needs is a container image. And so we're going to use that container image on Cloud Run, but you could also use that container image on Kubernetes or run it in anything else that runs containers. Okay, so that's going to take a minute to do the build. Once it does the build, it's going to do a deploy, and we'll see that. We'll come back and see that in a second. But what we're ultimately going to get is a URL that is running this application, and we'll be able to then tell our application to use that URL. So I want to show you how I am able to set that URL. So first, if we go down to Gradle.properties in my root directory, I have a property called server URL, and that's going to be the URL where my application is going to be up and running. So I uncomment that. Because I had it commented out, then it was just using a default, which we can look here in the Gradle build KTS file and see how this all gets wired together. So if a server URL is set, then, so it's not equal to null, then what I'm going to do is I need to figure out two things. One is I need the server URL, and I'm going to do this res value string server URL to the server URL. But I also need to set another property in the manifest, which is this uses clear text traffic. And so if the URL starts with HTTPS, then I'm going to set that to false. And if it is HTTP, essentially, then I'm going to set it to true. And this is just an Android way of letting the manifest know if it makes insecure communication network calls or not. Okay, now if that server URL is not set, then it's going to say, yep, uses clear text traffic is true, and I'm going to set the server URL to this 10.0.2.2.8080, which from the Android emulator 10.0.2.2 is your local host, your local machine. Okay, so now let's go take a look at how that actually gets used, that server URL and the clear text traffic. So here in my Android manifest, I've got this uses clear text traffic, which gets substituted in with this manifest placeholder thing. Okay, and then because I said res value string server URL, now in our activity, what I can do is I can say resources get the string that is identified by resource.string server URL, and that's how I get out my URL that we're going to tell the Android application to connect to. Okay, so let's go back, check back in on our build. Looks like this build packs is still running. It takes a few minutes to do this full build. Build packs does have a way to do caching, and you can use build packs on Cloud Build. So that's something you saw in the previous presentation, is how to use Cloud Build to speed up the Android build. Well, you can also use build packs to speed up your actual server build as well. And so this is Cloud Build is one option for how you could also do continuous delivery. So if you want to set up whenever you check into your Git repo or whatever, and do an automatic build and automatically create the container image, then you can set that up with Cloud Build, or you can use Jenkins or any other CI/CD service. But ultimately, you just need to run pack build and create the builder, create the container image, and then once you get the container image, then we have our deployment unit that then we can deploy. There's also a few other ways to create containers. So you can use a Gradle plugin or Maven plugin called Jib, which is an open source project from Google for creating container images and is nice and a great option as well. Or you can use just the plain old Docker files is the traditional way to create your container images. So lots of different ways to create container images, but I'm using build packs in this case. Okay, so we're just waiting for that to finish running. Should only take a couple more minutes, and well, hopefully not minutes, seconds. There we go. Okay, so there we go. Our container image is now built. It's doing Docker push to store that on the Google Container Registry. So pushing that up to GCR, and then once that's stored somewhere that Cloud Run can access it, then it will be able to do the deploy. Okay, so pushing up that container image takes a little while because there's a bunch of layers in this container image. There's a layer for the operating system, at least one. There's a layer for the JVM, getting the JVM in there because that's what we're running on, a layer for my dependencies in my application, and a layer for my actual application. So build packs do a great job of creating those nice layered that make pushing and pulling images faster with caching. Okay, so we did our Docker push. It started on the Google Container Registry. Then we did gcloud run deploy. We're deploying to Cloud Run. We give it an application name, project, platform. You can also use GKE through something called Cloud Run for Anthos, tell it the region. Now we give it the image that we want it to run, and then we're going to say we're going to allow unauthenticated access. Great, so then our application is now up and running, and now we can go open the URL for this. It should go out to the GitHub API, do the same thing that you've seen before, and figure out the latest Kotlin version and return the JSON. So what's happening on Cloud Run is if there are no instances currently running for our application, it's going to start an instance. So that means pulling down the Docker container, starting the process to run the application, and then once the application is ready to handle the request will go in to the container, to the application, and be handled. Okay, great. It's all working up in the cloud. One of the nice things about Cloud Run is that it's serverless, so there's no servers to manage, and it scales up and down based on your demand. Let's go take a look at the Cloud Run console so that we can see what this actually looks like in the UI. That was all kind of automated command line stuff, but of course there is a nice UI that gives us metrics. We can see revisions. That was my 4th revision that was deployed there 1 minute ago. You'll see that I did this yesterday and this morning while I was testing testing things. And so you can see the previous revisions. Of course, you can do traffic splitting across those, rollbacks, that kind of thing. And then we can see the logs as well, details. We can deploy new revisions, and of course, automate any of this for a CI/CD pipeline as well. Okay, so here we see logs from the application. The Ktor application is up and running and responding to requests. Great. Okay, so now let's go back to our application where we have changed the Gradle properties to point to that endpoint for our application. And then let's go rerun this. And when I rerun it, Gradle is going to use now the server URL, which becomes that resource value, which my application, my Android application then uses. And so if we go look here, then we're going to see the same thing that we saw before, but this time instead of accessing localhost, we get the request to the server, and we can come in and reload the logs, and we should see the GET request that came in and was handled by the Ktor server. So there we go. We got a GET request, which returned a 200 response there. And so, so that's our application, our Android application, now running on the connecting to a service on the cloud. Great. Okay, so that's what I wanted to run you through for the Ktor piece. You can find all the code for this up on my GitHub. Okay, back to a couple slides to talk about gRPC real quick, and then we'll wrap up with some questions. So gRPC is another option that you could use for doing Kotlin both on the server and on Android. The way that gRPC works is that instead of writing Kotlin classes to define our shared data objects, we write a protobuf file which defines our messages and our services for doing RPC. And then what happens is the plugins into our build take the protobufs and generate the actual code that then our application can interact with for these messages and services. So we get some great features. We get the protobuf support. We get bidirectional streaming with gRPC. Nice thing about this is that these are language agnostic. So you write the protobuf in a language agnostic format, and then what you can do is you can generate the stubs around those services for doing RPC for any language that you want. You get strong typing based on the stubs. You get the ability to evolve the protocol, so you can add new fields and not break compatibility, and then generate the serializers, generate the service stubs, generate the client stubs. So that's a basic run through of gRPC. Oh, and it's fast because it's based on HTTP2. So we recently launched gRPC Kotlin, which is Kotlin support for gRPC. So what this does is it generates Kotlin-friendly gRPC stubs. It's built on top of gRPC Java. It adds in some great Kotlin stuff like coroutine support and the Kotlin Flow API for streams. And then this plugs into Gradle and Maven builds through the existing protobuf plugins and available on Maven Central. Okay, so where you can learn more about that is to go to the gRPC on GitHub and then gRPC Kotlin. And what you'll find in here is there is an example Android application which has a server common Android, very similar to the stuff that you've seen before, but instead of Kotlin and Kotlin X serialization, it's got the protobuf and protobuf client and server pieces for doing the talking client to server. So, so if you're interested in the gRPC option, go check out that code example. Okay, so that is what I wanted to run you all through, is how to combine Kotlin on Android and the server. So hopefully that was a nice quick run through, and hopefully you know where to go to get started with learning more. So let's see, let me pop back into the Meet. Stop sharing my screen. We'll do some Q&A.
Right. Thanks so much, James. That was awesome. Let me switch over to this view here. And yeah, the first question for us comes from Dr. M. He's back, or she is back. Wants to know, what are your advice on Flutter using Kotlin versus Java? Right, this is a common question around building Android apps using Kotlin versus Java, for specifically though for Android third-party APIs.
Yeah, interesting. Yeah, I think generally the world of Android is moving pretty heavily to Kotlin. Kotlin has great interoperability both back and forth with Java. So so if I was writing a Android third-party API today, I would do it in Kotlin. I enjoy using Kotlin more than Java. I've done Java for a long time, and Java has a lot of great things about it. But for me, I really like the coroutine support in Kotlin. I really like the data classes, the null safety. There's just a lot of really great features in Kotlin that I take advantage of. Immutability as kind of a default is really nice. And so so I would if it was me choosing, I would choose Kotlin to build my Android libraries. And there may be some additional work that this would cause for people that want to use Java to interact with those. I've seen people have to create like Java friendly stubs around Kotlin APIs to make them be a little bit more Java friendly in the Java world. But I would rather go that direction than going Java with Kotlin wrappers. So, but that's my personal
Gotcha.
preference.
Awesome. And a reminder to folks that they can ask their questions. We have the Q&A link over yonder, as well as the live chat. I guess it would be over here on the video. Yeah. But if there's no further questions, we'll give it some time. I thought it was really cool, James, how you were able to really show that end-to-end development experience, right? This is somebody, who, if they were to just kind of go all in on Kotlin and try to build essentially full stack Kotlin, right? They got tired of the amorphous typelessness of JavaScript and decided to switch over to a typed purely, as your description says, a typed pure functional programming zealot approach, and kind of, but oftentimes we only see a piece of that slice, right? It's like how to use cloud with Kotlin or how to use Android with Kotlin, but to see that full end-to-end workflow of just the things that happen on the seam, so to speak, where you put the Cloud Run URL, things like that.
With Kotlin, you can take things even further because of Kotlin multi-platform. You can also build your web, like JavaScript UI in Kotlin, and you can build your iOS UI in Kotlin. So it's pretty interesting to see the ability for Kotlin to be used as a universal language for these types of applications, all the way from the back end to all the possible front ends.
Yeah, I mean, Kotlin's come so far. I remember, I forget what conference I was at. This was a few years ago when they were first introducing Kotlin, and JetBrains was giving a presentation about it and talking about how it was, still running on the JVM, but different. And I was like, this looks pretty good, all things considered. That was early days, but it's really great to see how far the language has come. When you first hear about a language, you never know if it's going to stick around, 3-4 years down the road.
Yep, exactly. Yep. Yeah, that's exciting times for Kotlin for sure.
So let's see if there's any other notes, questions on the live stream here. I'm not seeing any direct questions, but I guess if there's not any further questions, we'll wrap it up here. I want to thank both our presenters, James and Don, for joining us today. It was really great to have you on, James. Great to have Don on. And I want to thank everybody for joining us today on Cloud Talks by DevRel. And we got a question from Dr. M again. Any links for the ML and Kotlin? I'm not entirely. Are they talking specifically about doing machine learning with Kotlin?
Machine learning in Kotlin. That's a good question. I think that does seem like what that's referring to. And I know that there is some work going into machine learning with Kotlin. It's not as prevalent as Python and Scala is pretty prevalent in machine learning as well.
Yeah, it's interesting because there is some Java libraries around it. There's deep learning for Java, Java for deep learning, something like that. That's like specifically made on Java. So you would think that it would be portable theoretically, I guess.
Yeah, I think there is some support. I
Yeah.
think it's just not quite as far along as some
And
of the
then
languages.
they've clarified saying GCP deploying and monitoring, which feels different from machine learning.
Yeah, yeah. There is a number of resources around that in particular, but I think the short answer is that anything that the documentation refers to around Java and
Mm-hmm.
GCP is applicable to Kotlin
Oh,
and
interesting.
GCP. So if you want to use the GCP uh, libraries for monitoring, then just follow the Java instructions and it'll work fine in Kotlin, which is a really nice thing
Nice.
about Kotlin being that layer on top of
Right.
Java. If you want to use the Java libraries for talking to
Mm-hmm.
Spanner, then you can just follow the Java ones in Kotlin.
Cool.
You're good. So some things are starting to have Kotlin idiomatic
Yeah.
wrappers, but yeah, essentially anywhere there's documentation on Java and GCP, it applies to Kotlin.
Fantastic. So with that, we'll wrap it up there. Yeah, thanks everybody for joining us today. And for more technical content, be sure to subscribe to the channel Adventures in the Cloud and catch future videos and live streams. So until then, be well, be safe, and we'll see you next time.